How do you do, viewers? My name is Tuta Daniel, and today's lesson in physics, we're going to talk about speed, velocity, and acceleration. So what we need to know under speed, velocity, and acceleration is the definitions and the formulas. So we'll start with our first there, which is speed. So speed is simply the rate of change of distance with time. So speed is the rate of change of distance with time. So you can see that there's distance that is involved and time that is involved over there. So speed is simply the rate of change of distance with time. So speed is equal to the distance in meters divided by the time in seconds. So speed, I can say speed is simply the rate of change of distance with time. So our distance there in meters and our time in seconds. So the units of speed are meters per second. So speed is simply measured in meters per second. Why? Because we are dividing the distance which is given in meters and the time which is given in seconds over there. That's all to the speed. You move to displacement over here. So displacement. So displacement is simply the distance moved in a specified direction. So displacement is simply distance moved in a specified direction. An example is where I say, okay, you move 50 meters to your right. That's distance moved in a specified direction. That's what displacement is. We later on move to velocity. So velocity is simply the rate of change of displacement with time. So as we have already defined displacement as the distance moved in a specified direction. So we're saying velocity is simply the rate of change of displacement with time there. So velocity is equal to the displacement in meters divided by the time in seconds. So the units of velocity are also meters per second. So the units for velocity are also meters per second. Later on, move to acceleration over there. So acceleration, this is the rate of change of velocity with time. So acceleration is the rate of change of velocity with time. So I can say acceleration is equal to the final velocity minus the initial velocity divided by the time over there. So acceleration is equal to the final velocity minus the initial velocity. So when I talk about the final velocity, I can say it's the destination, and the initial velocity is simply the starting point there. So if I say the final velocity minus the initial velocity, so for example, I say the final velocity was 10 and the initial velocity was 0. So meaning the starting point was 0 and the final destination was 10. So acceleration is equal to the final velocity minus the initial velocity divided by the time taken. So acceleration, the units for acceleration are meters per second squared over there. So the units for acceleration are meters per second squared. Then we later on move to the abbreviations used under speed, velocity, and acceleration over there. So the abbreviations used. So you find these letters here, U, V, A, T, S, H, and G as questions, or you use them in formula. So we need to know what each of these letters represent. So we start with the first one, U. So U stands for the initial velocity. So when I say initial velocity, I simply mean the starting point where the journey started from. So initial meaning the starting point. Then we've got V, which stands for the final velocity. So V, the final velocity, I can simply say the end point, or where the destination is ending. Since initial, meaning the starting point, then final, meaning the final destination. Yes. Let us move to A. A is representing acceleration, as we have talked about acceleration previously. So acceleration. Then T there, talking about the time. So when you say small letter T there, it refers to time. Specifically small letter T, not capital letter T. Capital letter T refers to something else in physics. So whenever you see small letter T, it refers to time. Then I've got S. So S doesn't stand for speed, but it stands for displacement or distance. So whenever you see S in physics, it's not speed. It's either displacement or D or distance there. They're both in meters. Then we talk about H, small letter H. So small letter H simply represents the height. Then I've got G. So G is acceleration due to gravity. And we know that acceleration due to gravity here on Earth is equal to 10 Newton per kg. So this is our the first part of speed, velocity, and acceleration. Follow up for more.